Hi, this is Franck Baudin from Cosmos, and I would like to explain how the DPI engine has been integrated within openvswitch in order to respect its current architecture and to make the best use of the datapath in order to keep high performances. So let's first have a quick recall about how openvswitch is designed. So openvswitch has a flow cache, which is a data in the data path, and which is implemented in the Linux kernel, and you have an openvswitch daemon which contains the OpenFlow rules. So in the kernel you just have a cache. So when a client connects to a server via vswitch, what happened on the first packet? So this is a new flow. So the packet arrives in the flow cache. We have a cache miss as it's the first packet of the flow. The packet is sent via upcall into the vswitchd. We have a lookup in the OpenFlow rules, and the destination of the packet and the proper actions are found, updated in the flow cache, and the packet is sent out. The second packet goes directly through the data path as it has been cached. The data path entries expire after some time, so when the flow cache expires, we are back to the previous case where the packets are going through the vswitchd and the cache is updated. Cosmos SAM service aware module is the DPI engine plugin that has been added in the vswitchd daemon. So it sits just before the OpenFlow rules. So the idea in that case is to comply with the architecture of the openvswitch and to minimize the number of packets that will go through the openvswitchd and also through the IX engine, as packet classification can be quite expensive in terms of number of cycles. So this is why the DPI plugin is made of two parts: a flow table that gives track of the classification of the flow. So when the flow is classified, there is no need to inject the flow in the IX engine. So a lookup in this table is very quick, and a hit in this table in terms of performance is it's like not having the module at all compared to the original openvswitch. So when the first packet arrives, we have a miss. The flow table also, we have say, okay, it has to be classified. It's sent to the IX engine, so the DPI engine. The DPI engine do its job and extract metadata. Then the flow table content is updated based on the classification. So this is done. So sometimes you need 3-4 packets to classify a flow, but often it's just one packet of payload. The classification is updated in the flow table. Then we go through OpenFlow rules and we update the cache once the classification is done. Once the classification is done, the flow cache has been updated, we have a hit, and we have the same performance as if there were no DPI at all. When the flow cache expires, so we have a shortcut to avoid to go through the IX engine thanks to the flow table. So we have kept a track of the classification result in the DPI flow table. The classification is done, and there is just a function call and a function return which has been added to the original code. So this is very light. And then we update once again the flow cache, but this is OpenFlow regular code, and the packet is sent to the server. Well, yes, back to the former case, the datapath hit. So now I'll show you a quick demonstration with SSH. So the openvswitch in the middle sits between a client and the server. So this is a topology that I use also to explain how to use application extensible matcher. But here what I want to focus on is datapath and datapath content. So you will see that the client will SSH on the server and that the packets will be classified in the proper in the proper VLAN, and also that the data path will be used. So let's go with the demonstration. So we start the openvswitch, the regular parameters of openvswitch, and then that's the DPI plugin. I've put some parameters to have some verbosity because that's a demonstration, but you don't need to have much. So we configure the data path, okay, and then we check what we have. We configure, sorry, the vSwitch, and then we check that the data path is empty. Okay, so here we have I will TCP dump on the server, and from the client I will SSH on a non-regular port just to show that's real DPI, and I will. So if I SSH, you see that's SSH, proper VLAN, but if I dump, my entry is already gone because the timeout is quite quick in the data path. So if I do something like, and if I'm quick enough here, you will see that okay, all the packets arrive. The packets arriving here are in the proper VLAN. It means they have been classified. You have seen no logs here because you have not been into the DPI engine, because the flow has been already classified, and we just went through the flow table when the packets went up to the daemon just to have the application ID. So, and here, okay, so this expire. And in order to work properly, so what has been modified in the original code is that we unmask the 5 tuples, so IP, protocol, and ports of the flow that we run DPI on. So this is it for my demonstration. So don't hesitate to have comments on the implementation on openvswitch mailing list, and have a good end of day.